Alright, so we're still looking at 11.8, which is taking the surface area and volume of cones. And so, we've already kind of discussed earlier last week when we were looking at constructions of cones, how to find the surface area from our net. But again, here's our cone. In order to find the surface area, we want to find the area of that base, which is a circle, plus the area of this outer edge of the cone, I guess you could say. But that's actually given to us by the sector of some circle. So we're going to say in order to find the surface area of a cone, we take, and I'm going to say surface area is S. Surface area is equal to base plus lateral surface. Okay, so this outer edge of our cone here, that's not our base, we call that the lateral surface. So again, the base is some circle, and the formula for the area of a circle is pi r squared, where again, r is the radius of the base of our cone, plus the lateral surface, and we're going to call this length here L. Okay, so L, if we're looking at our cone, is going from the point straight down to our base. What is that length? H is our height this way, like if you could poke through the bottom of our cone here and go all the way up to the vertex, whatever that length is a height. So in order to find the lateral surface area, we're going to take pi times r times L. And L is the slant height, which is equal to the radius of the sector. Okay, so when we form that net, that bigger circle that we kind of took a portion out of to create that sector, whatever that radius is what we call the slant height. So then for volume, what we just discovered is that it's a third of the volume of a cylinder, which again, we always get volumes by taking the base times the height. And then the volume of the cylinder, that base, which is a circle, we get by taking pi r squared, then again times h. So there's the two formulas you need for 11.7. Okay, so we're going to try some examples now. So this first one, we're trying to find surface area. So again, for surface area, we have pi r squared plus pi r L. So let's just start by labeling what we know. 12 here is referring to the height of that cone. So that's h. 5 here, that's our radius. So what we're missing is L. We don't actually know what L is. But we have this nice triangle here. We know h is 12, r is 5, and L is our lateral length right there. So this length here is L. And so because we have this nice right triangle, we could say 5 squared plus 12 squared is equal to L squared. And then to solve for L, take the square root of that. So L is going to be equal to 13 is what we get when we solve for that. Okay, so we're going to plug in those values, L and R, into our equation here. So we have S is equal to pi times 5 squared plus pi times 5 times 13. So here we have pi squared, which is 25 pi, plus 5 times 13, which is 65 pi. And then if we add those together, we get 90 pi, which is equal to 282.74, and this is in inches. And because we're finding surface area, it's squared. Surface area is squared, volume is cubed. Alright, this next one, again, we're trying to find the surface area, so we'd be using the same equation. So we have S is equal to pi r squared plus pi r L. So let's label what we have. 7.8, that's the radius, and at 10, that's the lateral length L. So we actually have R and we have L, so we don't need to do anything extra to find like H, because H isn't necessary when we're finding the surface area. It is when we find the volume, but not for surface area, so we're good to go. So we're going to plug in what we know. So R is 7.8 squared plus pi times 7.8 times 10. So when we plug this one in, we get 436.18, and again this is meters squared because we're finding the surface area. Alright, the next two examples we have here is finding the volume of a cone. And so the equation that we're using for volume, again, is a third of the base times the height. And we said the base, the area of that circle, is given to us by taking pi r squared and then times h again. So we're going to see, what do we have? 7, this is our radius, and 13 is our height, right? Because it's this length going straight up and down. It's not the diagonal length. You can see here it's talking about the straight up and down height. So we can just plug in what we know. So radius, again, is 7 times our height, which is 13. So we have a third. 7 squared is 49 pi times 13. And for this one, we get 667.04 inches cubed this time because they're talking about volume. Alright, for the next problem, again, we're using the exact same formula, a third pi r squared times h. So, let's see what we're given here. Our radius, r, and then this is L, our lateral length, because it's referring to this edge. So what we need to find then is h, right? So again, this gives us a right triangle there. So we want to use the Pythagorean theorem whenever we have two sides, a right triangle, and we're trying to find the other side. We want to use the Pythagorean theorem. So if you plug in what we know, we have h squared plus 5 squared is equal to 8 squared. Right, our 2 legs squared is equal to the hypotenuse squared. So we get 25 is equal 64. And then, in order to solve for h, we need to subtract. So we take 64 minus 25, and we get 39. Take the square root, and for h here, we get 6.24. Okay, so now we're going to plug in h and r into our equation here. So we have a third pi times r, which is 5 squared, times h, which is 6.24. Okay, so our volume, take a third pi times 25 times 6.24, and at this point we're just going to plug it into our calculator, and we get 163.36, and again this is meters cubed because we're talking about volume. Alright, going on to our next two examples, our last two examples. So here we're given two similar solids. And so there's a couple of different ways you can do it again, either conceptually or you could use an equation for it. We'll do both ways. But I've drawn my two cones, and then we just want to go through and label it real quick. It says height of cone A is 6, height of cone B is 2, volume of cone B is 18 pi, and we want to know what's the volume of cone A. So if we just look at the scale factors for a moment, in order to go from A to B for a height, and that's just that dimension of our cone, and so like before if we're looking at length or width, that scale factor to go from 6 to 2 is a third, right? We're multiplying by a third. And now we want to go back in this direction some amount. So normally to go from 2 to 6, we would say we're multiplying by 3. However, because we're not talking about a dimension here, we're talking about volume instead, we're just not going to use the same scale factor we use for the dimensions of the cone. Area is different, volume is different. Remember we said for area, we square the scale factor. Guess what we do for volume? We cube the scale factor. So if you'd like to use an equation, the equation that we use is K is equal to the height of the cone, or if they're giving you the radius, you would say the radius of the cone, but whatever dimension they're giving you to work with, whether it be L, R, or H, you'll use that to find the scale factor. So here we're going to say the height of cone B, and remember you always do the new divided by the original, so cone B is the new one, cone A is the original, so the new, B divided by the height of cone A. So height of cone B is 2, and the height of cone A is 6, so that scale factor, when we reduce to 6, we get 1/3. Okay. So when we talk about volume, that scale factor is going to be cubed. So K cubed is equal to, again, volume of cone B divided by volume of cone A. Again, we do the new divided by the original. And so we can plug in what we know here. Well, K we know is 1/3. So we take 1/3 cubed. So 3 cubed is 9. So 1/9 is equal to the volume of cone B, which is 18 pi, divided by volume cone A. That's what I'm trying to solve for. I'm just going to call that V. So from here, I can just cross multiply. I have 1V is equal to 9 times 18. So V is equal to 9 times 18 pi. And when we get for our volume there is 162, and that's inches cubed. So here we're multiplying by a third, or we can say going in the opposite direction, going in this direction instead, we'd be multiplying by 3. So if I want to know what's the scale factor for volume, then I would want to take 3 cubed, and a 3 cubed gives us 9. So when we take 18 pi times 9, we get that new volume, which is what we've done over here. So you could think about it either way. Alright, and again, this is for similar solids. Just a quick note about that. That means the dimensions of those cones in proportion to each other are the same. Okay, composite solid. All that means composite solid is that it's made up of 2 or more solids. So here you can see we have a cylinder, and then we have a cone resting on top of it. So if we want to find the volume of the composite solid, we have to take the volume of the cylinder plus the volume of the cone. So volume is equal to volume, and I'm just going to write V of cylinder plus volume of cone. I'm just going to write a little reminder about what those equations are again. So volume, I'm just going to write as V. But the volume of the cylinder, again, we get that volume by taking pi r squared times h. Because again, that's our base times our height. Plus the volume of the cone, it's similar to a cylinder, but again, we have to take a third of the pi r squared h. So let's see what information is given to us already. 3, this is the radius. Notice this radius for the cylinder is the same as for the cone. So this is also 3 there, so we're given both of our radiuses. The height of our cylinder is 10, and the height of our cone is 5. Okay, so we have actually all the information we need, so we're just going to plug that in. So when we're talking about the cylinder, again, for the cylinder, the radius is 3. The height of our cylinder is 10, plus a third pi. We're talking about our cone now. The radius of our cone is the same for the cylinder, that's 3, times the height of the cone, which is 5. So we have 3 squared, so we have pi times 9 times 10 plus a third. 3 squared is 9 times 5. So we have 9 times 10, which is 90 pi. We have a third times 9, which is 3, times 5, which is 15 pi. So we have 105 pi here, which is equal to 329.87. And again, this is centimeters cubed. That's the volume of that entire solid. Okay, those are all the examples that I have for 11.7. So notice this is much easier than what we're doing with our exploration. But that exploration hopefully will be used as your foundational knowledge on how to do or how to approach the rest of these problems and seeing how they're connected.